I think it's my job as an organic chemistry professor to teach enough organic chemistry so that students in the biomedical sciences can interpret catalytic cycles mediated by enzymes in terms of the chemistry of what's happening. I don't mean what the enzymes are. I don't mean what they look like inside. I just mean what's happening. What's the chemical step that's behind, for instance, NAD plus and FAD. They're both dehydrogenation agents. So how do they act? Let's start with FAD. FAD is the molecule in the Krebs cycle which is responsible for taking off two hydrogen atoms from an alkane substrate, 6-in-8, and forming fumarate, the corresponding alkene. It dehydrogenates, you see? The structure of NAD plus is quite complicated. It's got a lot of stuff up there that will coordinate to the enzyme holding the NAD plus in exactly the right orientation. Don't worry about that. We're not concerned with that. We're concerned with the warhead region, which I've colored in yellow. That's a flavin. And flavins can pick up H2, two elements of hydrogen, and add them to give a reduced form. So you see, FAD going to FADH2 is a hydrogenation reaction of the flavin and a dehydrogenation reaction of the substrate. FADH2 going back to FAD is an oxidation of the FADH2 back to flavin and gives a reduced substrate. And if the substrate is succinate, we form fumarate and progress the Krebs cycle. FAD's best friend is NAD+, and they're friends because they're complementary. NAD is also a complicated structure. But again, the action end is this piperidinium I've colored in blue. NAD plus doesn't abstract H2, it abstracts H minus. It forms H2 stepwise with a little help from its friends. Let's see how it does that. NAD plus abstracts hydride, and when it abstracts hydride, the hydride is driven towards the para position of the positively charged ring. The electrons feed round, push, push onto the nitrogen and fill up the positive charge. Where's that hydride going to come from? It comes from the alpha carbon relative to an OH. It's the one next to the oxygen bearing a hydride. We're going to pluck that off. The oxidation of isocitrate into alpha-ketoglutarate in the Krebs cycle. And you could draw a set of arrows to say that, pushing in the electrons from the CH bond to the para position of the piperidinium, push, push onto the nitrogen. To me, that reaction looks hard. It will involve a high energy barrier. And enzymes are great at high jumping energy barriers. In fact, they cheat. They bring the bar down. But even so, NAD requires a little bit of help from that amide group at the 3 position in the piperidinium. What's that doing? It's there for a good reason. The amide simultaneously hydrogen bonds to the OH group. When it does that, it pulls on the H+. Keto-enol tautomerizes to give us the enol form of the amide. So it's pulling on that proton as the substrate, isocitrate, delivers that H alpha to the piperidinium. The piperidinium pulls on the H minus, and together they tug off the elements of H plus and H minus, giving a ketone, alpha-ketoglutarate. And of course, all the time in equilibrium, the enol form of that amide reverts back to its predominant form, the keto form. In summary then, NAD plus abstracts hydride and abstracts a proton too in an ionic type process. FAD abstracts 2 hydrogen atoms in what looks like hydrogenation of the flavin to give FADH2, less polar oxidation. I hope this little video has helped you understand the chemistry that goes hand in hand with dehydrogenation reactions, which are oxidations performed by NAD+ and FAD in catalytic cycles. Chemistry is there to help you understand biochemistry. Thank you very much for listening again. Bye-bye.
Akkor üdvözöllek a sószinte üvölt, amelyet a bűvöldön. Mosolyogva üdvözöl, a játék a sószinte üvölt. Engyűzett attól, az egészséglik a kezében. Míg a pillanatban ott van győzelem a szemében. A koncentráció érezhető, a tehetség agyon. Kettog a győzelemért küzd, úgy mint a nagyok. Lehetetlen, nincs akadály, csepp a fényen a meg a látvány. A stratégiája tökéletes, a reflexek gyorsak, ellenfelekesnek jelen rohannak. A magatok adna, a billentyűzet adta, az egészséglik a kezében. Mind a pillanatban ott van győzelem a szemében. A koncentráció érezhető, a tehetség agyon. Kettog a győzelemért küzd, úgy mint a nagyok. Nincs akadály, kepp a fényen a meg a látvány. A stratégiája tökéletes, a reflexek gyorsak, ellenfelekesnek elnek rohannak. Magunkban adnak, a billentyűzet kattogol, az egész siflik a kezében. Minden pillanatban